Continuing with the question 57. Moving into question number 57. In the circuit shown below, the current through the inductor, we will have to find the current through the inductor J1. Okay. So, a combinational circuit in the form of a bridge is given. Okay. So, what we are going to do is that we are going to redraw this circuit, and here it is 1 angle 0 amperes. Okay. So, I am assuming that 1 ampere is going into node A. We are going to consider node A, and if from the 1 ampere I2 splits through J1, I2 is passing through J1, then the current that is passing through this branch will be 1 minus I2. Okay. So 1 ampere is incoming, I2 is outgoing, 1 minus I2, the remaining current is flowing through this branch. Okay. So now we will be considering this loop with the A, B, D, A. Okay. So considering A, B, C, D loop, A, B, C, D, this is A, B, C, D loop, and we are going to write the equation as 1 angle 0 minus 1 angle 0, because this is connected in opposite, so it is 1 angle 0 minus 1 angle 0. Then here this is 1 into 1 minus I2, and here this is J1 into I2, okay, so it is minus JI2 equal to 0. From this you will get the expression for I2 as 1 divided by 1 plus J. So I2 becomes equal to 1 divided by 1 plus J. What is 1 divided by 1 plus J? 1 divided by 1 plus J is option C. So what is our answer? Our answer is option C for question number 57. Now moving into question number 58. A two-phase load draws the following phase current. So I1 of T and I2 of T. These currents are balanced if phi1 is equal to is what is the question. Okay. So I1 of T and I2 of T are given. This is a 2012 1 mark question. So I1 of T and I2 of T are given, and this is a two-phase load which draws the following phase currents. The currents are balanced if phi1 is equal to. So we will have to find out the value of phi1 such that the currents will be balanced. So here you can see the phase difference is to be balanced, isn't it? Im sin and Im sin is the same. Now the phase difference is 90 degree. Now when the phase difference is 90 degree, omega t minus phi2 plus 90 minus omega t minus phi1 is equal to 90 degree. Okay. The phase difference is 90 degree. Two-phase load. This is a two-phase load. So when it is a two-phase load, the phase difference of the two currents will be 90 degree. Okay. So the difference between the phases has to be 90 degree. So omega t minus phi2 plus 90 degree minus of omega t minus phi1 is equal to 90 degree. So you have to remember this condition that in a two-phase system the currents are balanced if the phase difference is 90 degree. Okay. And when you are equating this, you will have omega t and omega t cancel. So 90 and 90 will become 0. Phi1 minus phi2 is equal to 0, or the condition is phi1 is equal to phi2. Phi1 is equal to phi2. So these currents are balanced if phi1 is equal to phi2. So that means for question number 58, our answer is phi2 and the option is option B. Now moving into question number 59. Average power delivered to an impedance 4 minus J3 ohm by a current 5 cos 100 pi t plus 100 ampere is what is the question. So the average power delivered to an impedance, what is our impedance? Our impedance is 4 minus J3 and the current is 5 cos 100 pi t plus 100 amperes is what is the current. So the impedance is given, current is also given. So current is given, okay, and we can convert the current into polar form. Impedance is also given, impedance is also converted to polar form. What is V? V is equal to I into Z. So we have got the voltage. So the average power equation is half Vm Im cos phi. Average power equation is half Vm Im cos phi. Substituting the values into this, you will get the answer as 50 watts. 50 watts becomes the answer. So what is our answer choice? Our answer choice is option B, 50 watts for question number 59. Now moving into the next question, question number 60. If VA minus VB is equal to 6 volt, then VC minus VD is what is the question. Okay. If VA minus VB is equal to 6 volt, then VC minus VD is the question. So we are recreating the diagram, and what we are going to do is that we are going to put these things in a box. Okay, on the two sides there is no change, so the circuit will remain static. So I am assuming that the first portion is a network A and the second portion becomes a network B, and in between you have a 2 ohm resistor. Here there is a current source with a parallel resistance. I am converting it into voltage source with a series resistance. So it becomes 2 volt 1 ohm resistance. So what is to be found out? If VA minus VB is equal to 6, it is said that VA minus VB, the difference of voltage here is equal to 6. Okay, and if I is the current that is circulating, you can see VA minus VB is the drop 2I. Okay, so VA minus VB is equal to 2I, and VA minus VB is given as 6. So that means 2I is given as 6. That means I is equal to 3 amperes. Okay, I is equal to 3 amperes. So if I is equal to 3 amperes, the 3 amperes will produce a 3 volt drop on 1 ampere. Okay, it produces a 3 volt drop. There is a 2 volt source here. So what will be the total voltage difference of VC and VD? It will be minus 5 volt. So 3 volt drop is produced in 1 ohm resistance, and there is a voltage source. So it is both minus. So we will take it as minus 5 volt. So what is VCD? VC minus VD, it is minus 5 volt, and our answer is option A, which is minus 5 for question number 60. Now we are moving into question number 61. 3 capacitors C1, C2, C3 whose values are 10, 5 and 2 respectively have breakdown voltages 10 volt, 5 volt and 2 volt respectively. For the interconnection shown below, the maximum safe voltage in volts that can be applied across the combination and the corresponding total charge in microfarad, it is not, it's microcoulomb, stored in the effective capacitance across the terminals are respectively, is what is the question. This is a 2013 2-mark question. So we have 3 capacitors C1, C2 and C3. C1 is connected across C2 and C3. C2 and C3 are in series. Now Q is equal to CV. So similarly Q1 is equal to C1 V1, Q2 is equal to C2 V2, Q3 is equal to C3 V3, and substituting the values we will get it as 100 microcoulomb, 25 microcoulomb and 4 microcoulomb. C2 and C3 are in series. Okay, so in series the charge is the same. So the maximum charge on C2 and C3 will be minimum of Q2 and Q3. Okay, what is minimum of Q2 and Q3? Minimum of Q2 and Q3 is 4 microcoulomb. Okay, so the maximum charge on C2, C3 will be minimum of Q2, Q3, which is equal to 4 microcoulomb. Now what is the charge on Q1? It is 100, isn't it? So 25 microcoulomb, 4 microcoulomb will, the selection will be 4 microcoulomb. Now in series, the equivalent capacitance of C2 and C3 is C2 C3 divided by C2 plus C3, isn't it? So C2 C3 values are given as 10, 5 and 2. So for substituting the values, you will get it as C23 is equal to 10 by 7 microfarad. So we have got Q23 and we have also obtained C23. So once we know Q23 and C23, then we will be able to find out the value of V. So from this we can find out the value of V23 as 2.8 volt. So equivalent voltage is 2.8 volt. In parallel the voltage will be the same. So that means what is the voltage across 2,3? The same voltage will be applied across C1. So what is voltage across C1? Voltage across C1 will be again 2.8 volt. Okay, so then what will be the change in capacitance? Q is equal to C1 V1. Then we will be able to find out the value of Q1 as 28 microcoulomb. 28 microcoulomb. So what is total charge? Total charge is the previous 4 microcoulomb plus 32 microcoulomb plus 28 microcoulomb. What is the previous? This is the previous 4 microcoulomb plus the 28 microcoulomb. So 28 plus 4 will come to 32 microcoulomb. So what is our answer? Our answer is option C. The voltage, the effective capacitance across the terminal, the total charge in microcoulomb stored So for the interconnection shown below, the maximum safe voltage in volt that can be applied across the combination and the corresponding total charge in microcoulomb is what is asked. So what is the safe voltage? The safe voltage that can be applied is 2.8 volt, isn't it? And the total charge is 32 microcoulomb. So what will be our answer? Our safe voltage will be 2.8 and the total charge will be 32 microcoulomb. So that is answer for question number 61. Now moving into question number 62. The three circuit elements shown in the figure are part of an electrical circuit. The total power absorbed by the three circuit elements in watts is what is the question. So it's a 2014 1 mark question of set 1. So this is a source, and this is also a source. So the total power absorbed by the three circuit elements is to be found out. So we are recreating the circuit and we are considering this as a node. The current passing is 10 ampere and 8 amperes. So once it is 10 ampere and 8 ampere, here it is 2 amperes. Okay. So we will have to find the power at each and every point. So the first power point is 1000 watts. Okay. So it is 10 into 100. And the second power point is 8 into 80. So it is 640 watts. Okay. And then the third power point is 15 into 2. So it becomes 30. So the incoming becomes positive and the rest of it becomes negative. So what is total power? Total power is 1000. It is 1000. This is not 100. It is 1000 minus 640 minus 30, which will be equal to 330 watts, which is equal to 330 watts. So this is a fill up type numerical question. So what is our answer? Our answer is 330 watts is what is the answer. The total power absorbed by the three circuit elements in watts is what is the question, and the answer is 330 watts. Moving into question number 63. An incandescent lamp is marked 40 watt 240 volt. The resistance at room temperature 26 degrees Celsius is 120 ohm and the temperature coefficient of resistance is 4.5 into 10 raised to minus 3 per degree Celsius. Then its on state filament temperature in degrees Celsius is approximately. So the resistance of the lamp is to be found out. It's a 40 watt 240 volt lamp. Okay. So what is RT? It is V square divided by P. So it comes to 1440 ohms. Okay. So R0 is given as 120 ohm. In the question, R0 is given as 120 ohm. Temperature coefficient of resistance is also given. So R0 is 120, alpha is given, RT we have obtained RT also. So we are going to substitute this into the equation of temperature coefficient of resistance. This equation you have to put it in the box, write it down. RT is equal to R0 into 1 plus alpha delta T. So RT is equal to R0 into 1 plus alpha delta T. So 1 plus alpha delta T equals substituting this into this value, 1 plus alpha delta T is equal to RT by R0. Okay, RT by R0, we know RT and we also know R0. So we are cancelling it and we will be getting it as 12. So alpha delta T becomes 11 and delta T is 11 divided by alpha. Alpha is already given as 4.5 into 10 raised to minus 3. So our T comes to be 2444.44 degree Celsius, but our ambient temperature is given to be 26 degrees Celsius. So we will have to add ambient temperature to the filament temperature. So the total filament temperature will come to be 2470.44 degree Celsius. 2470.44 degree Celsius. So this is a good question. This is a different kind. It's a new kind of question which involves the temperature coefficient of resistance. So you will have to note down this question also as an important question. Now in question 64, two identical coupled inductors are connected in series. The measured inductance for the two possible series connections are 380 microhenry and 240 microhenry mutual inductance. So this kind of question we already know. If this kind of a question is coming, definitely you have to collect 1 mark from this. So two identical coupled inductors, we have already did this question previously. We will have additive connection and we will have subtractive connection. L1 and L2 are given as identical inductors. So we can put L1 and L2 is equal to L, and then you will have to solve the equations. Then you will get the value of M. Okay, so the value of M is here obtained to be 35 microhenry. So once you have the value of M, what is asked is the value of M, because the mutual inductance in microhenry is asked. So what is our answer? Our answer is 35 microhenry. So you already know how to do this question. In the same chapter itself, we have done this question with respect to a 10 ampere, 8 ampere question. So you have to remember these kinds of questions. Okay. So here the two possibilities are given, plus 2m and the subtractive minus 2m. Okay. So we will be making equation number 1 and equation number 2, and substituting L1 is equal to L2 is equal to m. You will be obtaining by mathematical simplification the value of m. Okay. So this is the answer for this question. Going into question number 65. In the figure, the value of resistance R is 25 plus I by 2 ohms, where I is the current in amperes. Okay, the current I is to be found out. So we will have to find out the value of current I. So taking down the figure once again, R is given as 25 plus I by 2. So what is I? I is equal to 2R minus 50. I is equal to 2R minus 50. So we have obtained the value of I, and we are going to apply KVL in the loop, in this loop. So this is 300. 300 is equal to I into R. Okay, or 300 is equal to I. What is I? It is 2R minus 50 into R. And you can solve this. Then you will be getting it as R is equal to 30 ohm, or R is equal to minus 5 ohm. Can resistance be negative? Resistance can never be negative. So we will have to consider R as 30 ohms. Okay. When you are considering R as 30 ohms, putting the value of R into this equation, you will get the value of I as 10 amperes. Okay. So it is 2R minus 50. R is equal to 30 means it is 60 minus 50, or I becomes equal to 10 amperes. So what should we found out? What should we find out? We should find out the value of current I. So what is our current I? Current I is equal to 10 amperes, isn't it? The current I is equal to 10 amperes. That is the solution for this question. Now moving into question number 66.